Hello again, my friends, and welcome once more back to the Invisible College. And it's really good to be with you because I haven't been able to give you a lecture last week because I've been very tied up with other things. I've started writing another book, which is really exciting, and that takes a lot of my time and energy. So I will keep producing lectures for you, and I'll keep doing newsletters for members of the college. But you're going to find that they maybe won't be quite as frequent, at least for now, as they have been, while I get my book and another lecture series together. And so the fruit is going to be further down the line where that's concerned. But it's very exciting times, and I think 2024, I think we're all going to have our hands full. I think it's going to be quite a year. Anyway, enough on that. We're talking about the electric universe, and the present lecture is going to be called Birkeland Currents, the Connecting Wires of Space. Now, before I go into that, I just want to say a few words that while I'm doing these lectures on the electric universe, I'm not going to go into the subjects in the sort of depth I would with some of my other subjects, partly because I don't feel qualified to, partly because it gets really complicated when you really start delving into the nitty-gritty, and partly or mostly because I want to give you the overview. I want to give you the context for what we're talking about rather than the detailed equations and the fine stuff that has to be argued with physics professors to get it accepted and all that. I leave that to people who are better able to do that. I want you to see where it fits into the larger context, the philosophical context of what we've been discussing with other things on the Invisible College. So without more ado, let's get into the present lecture, the Connecting Wires of Space. Now, as you know, in the last lecture I talked a bit about Robert Fludd, and those of you who have been with me for a time will know that he's one of my favourite past philosophers. Lived in the earlier part of the 16th century, the earlier part of the 17th century and the later part of the 16th century. So he was alive during the reigns of Elizabeth I, James I, and a bit of a reign of Charles I. So he's a very interesting period of the history he was alive in, what I would describe as the Rosicrucian era. And that's got nothing to do with the cults in California or anything like that. It's to do with some pamphlets, sort of scientific pamphlets that were published originally in Germany and then later in France and Britain and other places, detailing ideas for a revolution in science. So he was very much connected with that, and he wrote a number of books. But that's not what we're going to talk about today. I bring him up because in our last lecture we looked at my favourite diagram, which again you'll have seen over and over if you've been with me a while. It's called the Integrae Natura. I'll say that again. It's called the Integrae Naturae Speculum Artisque Imago, which translates into English as mirror of the whole of nature and the image of art. So there you have it. It's a sort of universe image with God at the top, rings of angels at the top, the outer three rings, and the rings of the stars inside, and then the planets below them, and then the physical world, and so on. And you have the figure of nature representing Mother Earth, I believe, standing there, and she's attached by a chain to God at the top and a chain to man at the bottom. And we'll look at that in more detail. So nature is shown as a naked woman, a personification of Mother Earth. And she is connected to God by a chain. Actually, I think they say it's a golden chain. In other words, she is under his control. He's got her by the wrist, the chain. He's the puppet master. He's pulling her chain. And then you go down, you see she's holding another chain in her other hand. If I could get that to change slide. There we go. She's in turn holds another chain or lead that connects her to an ape. You can see him sitting there. And he represents man. He sits on a globe and uses the instruments of science to try to understand the world in which he lives. So he's got a model of a globe and he's got a pair of, it looks like dividers, and he's, trying to understand what is this globe I've got here. And he's fully intent, he's a scientist, he's fully intent on what he's doing, trying to understand the laws of nature. But he's so intent on his work, he doesn't notice either nature or God. He doesn't look up and see what's really going on. He's focused on the physical, material world. So that's the situation of material science, material scientists. And Fludd seems to have recognised this way back in the early 17th century. I think this was published around about 1620. So, very interesting and wise man. So, and I regard him as one of my spiritual teachers, you could say. So what are these chains of connections? How does God communicate with the lower worlds? One answer to this question is through electrical forces, and that's what we're going to be looking at today. So as I say, I'm looking at this situation from a philosophical rather than a scientific point of view, but I will put links in the box below. If you go on to details, you get a whole load of stuff from the author or the recorder, and I'll put the links in there for other lectures you can follow this up with. And I'll be doing that with the lectures as we go through this little series. So let's start with Benjamin Franklin doing an experiment with a key, a famous experiment that was carried out. He had flying a kite into a storm, and he was trying to see if the storm, the electricity was up there. They'd already found out quite a bit about electricity by this time, but he was looking up to see if there was electricity in the clouds and if that was causing lightning. So, very, very foolhardy experiment, I have to say. He could very easily have attracted a lightning flash down that string and threw his key and killed himself. But it seems that he didn't. He seems to be lucky. And he saw a spark coming off the key to his hand, a little lightning flash. So there wasn't too much energy up there at the time, lucky for him. So that starts to be the origins, you could say, of this whole idea about studying terrestrial electricity in the modern world. They may have been doing things like this back in the times of ancient Egypt, for all I know. But in modern times, that marks a new beginning. Now, what are we talking about? Well, we know that the Earth does have electrical forces working with it. Certainly you know all about the magnetic field of the Earth. If you've ever had a compass, you know it points north, or more or less. The magnetic north is not exactly right for true north, but it points north. And that's been known since at least the time of the Vikings. They used to take lodestones, and you can get certain stones which are magnetic iron, and they would tie a string to them, and they'd know that it always pointed towards the north. So although they used the stars as well, they used the North Star in particular for navigation. If it's a cloudy day, you can't see the stars, can you? In Northern Europe, it's very, very often a cloudy day. So you need to have something else, and they had these lodestones that would tell them where north is, and they could work out from there which was south, east, west, whatever, and steer their ships in the right direction. Masters of navigation. Perhaps a descendant of the Vikings was Dr. Christian Birkeland, who was Norwegian. And he was fascinated by the Northern Lights. And he decided that this must be something to do with electricity. So he very bravely went up with a scientific team to the north of Norway, and they were carrying out experiments with compasses when there were these electrical phenomena in the northern lights in the air. The sky was lighting up, because he was convinced it was an electrical phenomena, and he wanted to see what effect these things had on the magnetic field of the Earth. Very practical scientific thing to do, actually. And the weather terrible conditions up there, You can imagine you get these lights in wintertime, and wintertime in the very north of Norway is going to be very cold, and you've got to go out into the fields or where you can see them properly. Not an easy job to do, but they did it. And he deduced that these northern lights were a result of electricity coming into the Earth from the sun. And he postulated that the sun was throwing out electric particles that were coming in to the North Pole of the Earth and into the South Pole. And that was what was causing these phenomena. Now, of course, that reached a lot of opposition. But he carried out also experiments to prove what he was saying. And he carried out laboratory experiments. And this was a famous experiment he carried out called a Tarella. I believe he took this cabinet around to theatres and places to show people so they could see for themselves. And unfortunately, it gave him the reputation of being a bit of a magician, not to be taken too seriously by the scientific community, which is absolutely tragic, because he was actually a brilliant scientist. He should have received the Nobel Prize for his work, but he never did. But what he was doing, he had a magnetized ball in the middle there, representing the Earth, and then he had cathodes around it. I presume there was an anode also connected to the Earth, or the Tarella, and he fired cathode rays, which is electrons, at the ball in a vacuum chamber. So this is a vacuum chamber. And he found something very, very strange. The lines of force formed around the poles like that, and caused lights. So he had actually proven through experiments what he was proposing was the cause of the northern lights. It was to do with electricity coming to the Earth. And he published these ideas in his books. Unfortunately, he received a lot of opposition and flack, particularly from the astronomy departments. They said, no, there's nothing to do with it. Yes, there might be some electricity and some plasma being formed, but it's resulting from friction between particles in the Earth's atmosphere. Space is empty, there's nothing there. There's no flows from the sun or anything like that. It's all just empty space, and it's just particles, atoms, and they cause friction, and that causes these lights. And because the people who were arguing this were some very big names in astronomy, particularly from England, his theories were shelved, and the poor man ended up, going to on lecture tours, and he went to Japan, a broken man, and he committed suicide there. So it's a very, very sad story of how scientific bigotism, is that the right word? Bigotry, can destroy good men, good scientists, good women as well, if you're challenging the orthodoxy, and he was certainly doing that. Anyway, we now know that the sun does throw out material. We now know that space is not empty. It's a very fine plasma, as it's called. Like you get inside a vacuum tube. And matter in space is mostly in the plasma state. And what that means is where you have an atom, say an atom of hydrogen, has one proton and one electron, or you might have an atom of oxygen with lots of electrons going in different shells, and you have the core nucleus. Well, what happens with plasmas is some or all of those electrons get stripped off. So you're left with charged particles, the cores of the nuclei of the atoms, and you have clouds of electrons. And these go into a state that's referred to as the plasma state, but they don't behave like a gas. And this is one of the big problems that we have with trying to get the electric universe accepted by the scientific community, is that they're caught up in meteorological ideas about winds and nautical ideas about bow waves and bow shocks and explosions. They always think in terms of gases and big bangs, and they can't see that plasma is actually the fourth state of matter. Ancient people knew this. They referred to it as the element of fire. And they understood, if you read the Hermetica, it tells you how the air and the fire went upwards and the stars were formed of fire. What they meant by that is plasma. And plasma has very different properties from gas. For one thing, it can be bent. You can bend and actually a candle flame, for example, is actually plasma because it's fire. It has charged particles in it. And you can bend that with a magnetic field. If you have a strong enough magnet, you make a flame do that. I've seen it, it done. Certainly on YouTube, I've seen it done. I haven't got a strong enough magnet myself to do it, and I wouldn't want to do that. It might interfere with other things, but that is something that can be done. So we know very well that the sun throws out these eminences, usually from sunspots. It has eruptions, and you read about this on, or you see weather reports saying that the sun has thrown out an X-ray flare or something like that, and they warn that it might affect satellites, it might affect communication signals and things like this. And sure enough, when the flare, if the Earth happens to be in the way of it, they will get much increased northern lights when that flare, the material from that flare arrives in the Earth. And it wasn't until the 1960s, actually, when they started launching rockets in space. I think there was the Pershing prototypes of the missiles, and they put detectors on these missiles or these rockets going into space, and they discovered there is actually a flow of electricity coming to the Earth from the sun. And this we refer to as a Birkeland current, and that's a proper name for it. They don't like to, the astrophysicists don't like to use that term. They don't want to admit they were wrong. They still refer to it as the solar wind. But it's not a wind, it's a current. And in this current, you get both electrons and nuclei, protons, or larger nuclei flowing, and they form separate layers. That's a whole other subject of plasma physics I'm not going to go into too much here. But you get the flow of positive and negative ions together. And when you have a flow of positive charges or negative charges, you have a current, an electric current. On Earth, we only ever really experience flows of electrons. That's why we call it electricity. These small particles, or maybe they're waves, that you have this whole wave particle duality, don't you, in physics? But we only, experience the movement of electrons, and they don't actually flow through the wires that we connect them with. They flow on the surface, nearly all of them. So that's why you have a flex that you connect your toaster to, and that flex, if you cut it open, you see it's a bundle of thin wires together. that gives you more surface area for the electricity to flow through. That's why they do that. Also, it makes it more flexible than a cable. A cable, you have either one or more big thick strands, and it's not easy to bend those. So anyway, Birkeland, God bless him, was proved right. And you can see the northern lights today, these curtains of lights, and very often they will see, and I have seen footage of this. I haven't actually been up that far north in wintertime to observe it myself, the northern lights, but I've seen plenty of film of it, and you can see these curtains actually rotate and they move very, very slowly, but in time, you know, when they can time-lapse photography, do they call it, you can see how they rotate. And one curtain, or one, you imagine these curls around the Earth will be turning one way, and the next one out will be turning the opposite direction, and they go back and forwards. That is also very typical of a Birkeland current, but we'll come to that more in future lectures. So you can see here what really happening. You're getting flows, and the flows go both ways actually. They go into the North Pole and they come out. And our Earth is actually electrically charged. You've heard of the ionosphere. It contains ions, and they're held in by the magnetosphere. But the Earth itself, the actual body of the Earth that you're standing on, is very much charged negatively with respect to the space above it. And actually I think it's something like 100 volts per meter. So there is actually a difference in voltage between your feet, and if you're like me, you know, I'm 6'2", getting on for 2 meters, you've got 200 volts difference between your feet and the head. I don't understand it myself quite how this works, but that is you know, it's in layers, and there are, you perhaps are not connecting a circuit. That's why you don't feel it. But there is a voltage potential between the Earth and the ionosphere. If they ever succeeded in putting, there has been this idea of taking material into space instead of having a rocket to carry it up. You have some kind of space lift. So you have some kind of space station or something up there already. You haven't got to launch it again. And you have a big chain coming down from it to the Earth, or a big cable or something, all the way down. You hook things onto that cable, and then you can rotate it. Perhaps you have a round loop, like a bicycle chain or something, and you have maybe a big generator on the Earth. You charge this thing so it will go round and take the stuff up without you having to launch a rocket. Well, if they ever did that, they'd cause such a huge electrical explosion between up there, the ionosphere, and down here, the surface of the Earth, they'd all be killed, for certain. You know, the Earth is actually a charged capacitor, and that's what Birkeland's ideas were leading to, and that's what a lot of the modern electric universe people are working on, those ideas and developing them further. But we're not going to go into that. I want to go rather differently now. Now, you may have heard of Michael Faraday as a famous British scientist, particularly in the Victorian era, and he used to give demonstrations in what they call it, the Royal, not the Royal Foundation, it's not the Royal Society. Anyway, they still do the Christmas lectures from there in Mayfair. What was his house, and there's a lecture theatre there, and he would demonstrate things to people, a lot of things to do with electricity. In fact, he framed what are called Faraday's laws, laws of induction. Induction is when you have what's called a solenoid. You have a tube and you have wires run around it. You maybe connect that up to a circuit, and then you push a magnet into the tube, and it inducts electric flow into that circuit, depending on the number of wires you got, or the twists on the wire, so you have a stronger or lesser voltage generated or current. So Michael Faraday is famous for that and for demonstrating that. He also invented something called a monopolar motor, or homopolar motor, I think it's called. But he was a scientist, inventor. He wasn't really a theoretician so much as a practical, hands-on experimentalist. And one of the things he developed was what's called the Faraday cage. And there you can see one. If you sit inside a Faraday cage, it doesn't matter what sort of electrical things are going outside, that the cage will keep it out from coming inside, the lightning or whatever. So there's a little tip here. If ever you find yourself in a thunderstorm, if you've got a car with you, get inside it and stay inside, because the car's made of metal and that will act as a Faraday cage around you and will protect you from lightning flashes. Don't go and stand under a tree. It might do the exact opposite and act as a conductor for the lightning to come down and strike you. And lightning can be very, very dangerous. I have a friend whose partner was out canoeing and a thunderstorm started, and he was actually killed by a lightning flash because of the flatness of the sea at that point. I suppose his paddle or whatever he's using, or maybe himself, was the highest point there, and the lightning came down. It killed him instantly. So it's very dangerous, lightning, and it's something you have to be aware of. And if you do find yourself out in a thunderstorm and you feel the hairs in your head starting to rise, lie down immediately, because the lightning doesn't only come down, it also goes up. It goes up through you from the earth to join the flash coming down as well. One is positive, the other's negative, and they join together. We're not so aware of the upward moving current because it's usually in dark mode. That's something we'll talk about later. We see the downward coming one because it's in glow mode or arc mode. We see that, as you see on this picture, with the lightning hitting that cage and going down to the ground. Now, someone else who was very, very involved with this sort of work was this man, Nikola Tesla, who's become very famous recently. He's almost regarded as a prophet or the ultimate genius, or the man who was discovering the free energy, that if it only had been listened to, we would have free electricity, we wouldn't have to pay for anything. Well, I don't know about that so much. He was a genius, but his genius was built on the work of other people as well. He didn't do it all himself. He reached some very important conclusions and very important next steps, but he wouldn't have reached those if there hadn't been other people doing a lot of work before him. So I have sort of qualified admiration for him. Yes, he was a genius, but geniuses don't work in a vacuum. They're standing on the shoulders of others before them. Anyway, he invented the AC generator, which was a huge step forward. Now, they had AC generators before, but not like he developed it. He made one that was generating from motion directly into AC current, and that hadn't been done before, as far as I know. Yet they had generators that they could turn DC into AC, but they hadn't done it this way. So that changed everything where electricity is concerned, and everything you do with electricity is very much down to this invention, discovery of Tesla's, the AC generator. But he did invent a lot of other things as well, including the so-called Tesla coil. Now, I was telling you about the pushing a magnet into a solenoid and how that generates electricity. Well, there was another thing you can do. You can have a piece of iron, sort of maybe a ring of iron, and you have coils on one side of it, and then that leads to a circuit, and you can put coils on the other side of it, not connected directly to the first coils, and they pass a current through the first coil, and it will induce a current in the second one. Now that's important because if you put more coils on the second one, put 1,000 on there and only 100 on here, you'll get 10 times the voltage on the second one. You get less amperage, less current, less amperes measure current, volts measure potential difference, and there's a difference between that. But you'll get more voltage on the second one if you have more coils on it than the first one, and vice versa. You can downstep the voltage as well. So that gives us the basis of what are called transformers, and when you put AC current through transformers, you can make very large currents, and that's one of the things Tesla did. He created these Tesla coils which have a lot of turns on them and create very high voltage. And the voltage can be so high that normally air doesn't conduct electricity in the ordinary state unless the voltage is high enough. And you can get the voltage really high, you get it jumping from one thing to another, just like lightning. So this is another display that lightning is actually electricity moving through air. And he demonstrated how that could be done. So there's another of his, he's like Faraday in many ways. He liked to carry out lots of experiments. And here you see him sitting there. He hasn't even got a Faraday cage around him. He's very trusting that that lightning flash is going to go from one object to the other object. It's not going to flash across to him. He understood his electricity quite well by that time. And electric flows are subject to different laws from flows of gases or flows of water or whatever. And if you understand the laws of it, you can use it. And that's what we do in the modern world. We use it in all sorts of ways. The computer that I'm recording this on, the video that we're recording, it's all running on electricity. And that electricity is coming down to the house from the electricity board and the generators that are making it, whether they're windmills or solar panels or more likely coal-fired or gas-fired generators. They're able to supply my house with a 230 or 240 volt AC electric flow, and from that we can run all sorts of machines, including these ones. And you do the same with your house. And you can thank Mr. Tesla here that you can do that. Without AC current, we would not be able to do all that. So he also invented the plasma ball. And now I'm going to show you this. And for this, I'm going to have to turn the lights out. And I want to show you certain things about this. Now, I hope you can still see me, just about. I have a plasma ball here, and you can see it here. And inside it, there is actually a Tesla coil. So it generates quite high voltage in there. And when I switch it on, you can see the flows of electricity. Now, this is working in much the same way as a strip light works, or a neon tube. You have a high voltage inside there, and you have a very low density gas. In this case, probably a mixture of neon and xenon or argon or something like that in there. And the high energy plasma coil wants to discharge, and it does so to the globe on the outside here. So, but if I put my finger on it, you can see, you've probably seen this done before. You can see how much of the flow goes to my finger, because there's better conduction from my finger than there is in the air surrounding the globe. But there's something else I want you to understand here is that in the laws of electric flows, where you have electricity, and this is a mixture of ions and electrons, when you have a flow going along through the sky or through the air or anywhere inside here, as it flows, it generates a magnetic field around it. And the magnetic field has the effect of pinching the flow. And a low energy flow through a plasma you can't see. It goes in what's called dark mode. It's still flowing, but it's a relatively low flow. It's in dark mode. When you increase the voltage, increase the amount of energy that's being pushed through that plasma, so the field, the magnetic field it generates increases, and it pinches on and it squeezes it so that the flow goes down narrower and narrower lines. And you can see those lines are narrow. It's not just distributed evenly around the ball. And that these lines that you can see are actually what's called Birkeland currents. And they are twisted together. You can't really make it out in this too well. But if you looked at it very closely, you would see that there are two filaments together. Now, I want to demonstrate something else to you while we're here with this, and that is the electric field. That plasma, the Tesla coil in the middle there, is actually generating an electric field which is much larger than the plasma ball itself. I can demonstrate that for you using a fluorescent tube. So if I hold up the plasma ball and I bring the tube without the plasma ball, where can I put that over there for a minute? There is the tube. And if I bring the plasma ball closer to it, you can see how it lights up. Yeah, that's because the electric field being generated by that Tesla coil in the middle is agitating the coating inside the tube, just as if there were a flow of charged plasma inside the tube. It does the same thing, and you get fluorescence of the tube. And you probably maybe heard about this, but if you take a fluorescent tube like this and you go out to a big pylon or somewhere and you stand under it with your tube, the tube will light up, and that shows that the pylon, or the electric wires running along the pylon, big cables, they're carrying very high voltage. That creates a very large electric field, and it will illuminate your tube. And here's another word of caution: never ever climb up one of those pylons. You might be thinking, if I climb up it, I'm not going to touch the wires, they're well out there on their arms, I'll just climb up. A bit of fun, isn't it? Climb up the tube. Well, you're quite likely to get a lightning flash come off those wires, because there's a big electric field there, and you could very easily be killed if that's switched on. So never ever go climbing up electric pylons. If they're switched on, it could be deadly. So this is all to do with the whole idea of electric flows in space. A little plasma ball such as this one is in miniature, but this is happening maximally with other things, in particular with our sun, and we're going to have a bit of a look at that. Let me turn it off. Just open the curtains again. So I want to take you to another gentleman here. This scientist was Swedish, Dr. Hans Alfvén, who's a Nobel laureate for physics, and he lived between 1908 to 95. And he was originally an electrical engineer, designing these pylons with big wires and flows and things. He was into all of that. But he became a professor of plasma physics. He got very, very interested in this whole idea of plasma. And here you can see why, that in the early days particularly, they were getting a lot of these short circuits, you could call them, where the electricity was jumping from one thing to another, and that could be very dangerous. It could start fires, it could kill people. So they needed to know more about what was causing this and how it could be better controlled. And so that's how he got into this field particularly. And he recognized that there was this whole link with the concept of lightning and plasma, and the plasma that was being jumping from one wire to another was actually just like lightning. And instead of thinking, oh, that's just interesting, he started thinking about, well, how does the lightning work? What's causing all this lightning, and how does that fit with the sun and the whole Birkeland current thing? He knew about that. So he started working on all of that, and working on about how there was electricity in space. And people at first, they were all saying, oh, there's no electricity. Yes, of course there's electricity everywhere, but it's all balanced out, isn't it? It's all neutral. So if it's all neutral, there's not going to be any current flow, is there? It's just going to be winds. Well, it's not. And the thing is that he started realizing that planets are charged differently from the sun. They're charged differently from each other as well. So that you can get flows of electricity from the sun to the planets and from one planet to another maybe as well. So this whole idea of the connected universe was something that began to interest him, but he's particularly interested in the sun because the sun is very, very active, and he could see that these prominences that you see in pictures of the sun coming out are electrical in nature. They're not just wind being blown out or magnetic fields or something like that. They are actually electric flows, and very often you get a prominence that will fling out stuff, but a lot of it will be drawn back into the sun either by electric forces or gravity, and you get looping between sunspots. The sunspots are very high magnetic areas on the sun's surface. So he started researching all of this, and he developed a model. Actually, there was a guy called Hans-Jürgen who had been doing work on this before him, but Alfvén developed a more comprehensive model of a circuit involving the sun, that energy would be going out of the poles, flowing out to the heliosphere, and coming back in at the equatorial level into the sun. So you had a circuit. You had a northern latitude circuit and a southern latitude circuit. So he was postulating all that. I'm not going to go to it in detail. I'm going to give you some links about all this in due course. But what I want you to get into your head, and the idea is that you could have a flow, that the sun could act like an anode, and the outer space around it, and the planets as well, would be like cathodes. Now, for those of you who've forgotten your physics, an anode is positively charged and a cathode is negatively charged. And when I first heard this idea, I thought, well, that's interesting, but how does the anode maintain its positive nature in respect to the cathodes? Wouldn't it just receive electrons and get neutralized and that would be it? Well, the more complicated version of this story is that you get flows both ways, and the sun is sort of breathing actually. It's taking in positive and throwing out positive, it's taking in negative and throwing out negative as well. So you have this idea of this kind of living sun doing electrical things, just like you do in your own body. You know, the acupuncture flows in your body, the acupuncture meridians are electrical flows, and according to how they are, it will determine if you're feeling well or not, or if you have a particular problem with some organ. But that's, again, is another subject. I'm not going to go into here. So he designed this basic model of the sun as this electric body. Now, Dr. Donald Scott, I'm happy to say we have someone now who's still with us, and I actually was emailing him and exchanging emails last week. He's very much alive, a wonderful man, a great friend, and he's taken Alphine's model and he's worked on it and developed it further. He himself is a former electrical engineer, professor of electrical engineering and plasma physics, so he understands the difference between gases and plasmas in a way that, unfortunately, astronomers, they have this blind spot. They don't understand about the importance of electricity. The electrical force is 10 to the 38 or 10 to the 39 times as powerful as gravitational force. So when they talk about gravitational lensing or gravitational this, that and the other, if you have electrical forces operating, they just obliterate anything to do with gravity. They're so much stronger. 10 to the 38 or 39, you've got to put 38 or 39 zeros after your 1 to realise what that means. It's not 39 times, it's 1 with 39 zeros after it times as much. It's extraordinary, and that's what the power behind galaxies, it's the power in the universe that drives it, is clearly electrical. And actually the Milky Way or other spiral galaxies are actually, if you look at them from the electrical viewpoint, from the point of view of electrical engineers, they are a very, very much scaled up version of a homopolar motor, as proposed by Faraday. So, as above, so below. It all works. Once you put the electrics into this situation, everything becomes much clearer. You can forget about black holes, dark matter, dark energy, and all that nonsense. The universe works using primarily the electric force. I don't say it's the only force, and I don't say God has to work that way. There can be other ways. It could be things much higher. But from the point of view of the physical universe, the electric force is the strong force. And Donald Scott's done a lot of work on that. Now, you see talked about the solar wind, and when you pick up any book on astronomy, they talk about this wind. It's not a wind, it's a current. And currents carry energy, and currents are affected by electric fields. And one of the things that's been discovered, and Donald Scott has talked a lot about this, is that the field between the current, the sun, and the outer parts of the solar system, the sun is surrounded by a bubble. We call it the heliosphere. That's the sphere of the influence of the sun in the universe. Hard to explain this, but think of it as being like an egg. And we and all the other planets are inside that egg, as is the sun. And the outer limits of that are negatively charged compared with the inner parts. So you have an electric field. I showed you the electric field with the plasma ball stretching out beyond the plasma ball. It's just like that with the solar system. There is a field, an electric field, a spherical electric field around our sun that stretches way out into space, at least twice, maybe more, to Pluto, going way out, and eventually it reaches what's called the heliopause, and they sent, those rockets out there that initially went out to take pictures of the planets. What were they called? Voyager, I think is the right ones. And they sent them to look at the planets and take lots of photographs. They launched them in the 70s, I think. And they sent all amazing images back from the planets, gave us our first proper view of them. And then they carried on, and nobody thought they would still be working, but they are. And they've gone right out through the heliopause, and they're shown an electrical shock as they went through the passage, and they moved from the solar-influenced egg into the ambient galactic current flows that go out there. So we are getting real data now about how everything is connected electrically. The sun is connected to the earth by the flow of a current. They call it the solar wind. It's really a Birkeland current, and it goes in and out of the poles. And the earth is like an electrical egg. It has an upper atmosphere, it has an ionosphere, a magnetosphere, and it's contained in that. If the magnetosphere failed, the ionosphere would disperse, the atmosphere would disperse, and the Earth would die. It's as simple as that. So the reason we have a living planet here with water and air, and held in is because of the electricity. And I can't prove this, and I haven't really investigated it further, but I suspect that the magnetic field of the Earth is actually induced, like an electromagnet, by the currents that are flowing in and out of it. It's not like it's got a permanent magnet in the middle. It's not a big lump of iron. There might be iron there, but that's not what's doing the magnetic field, except like an electromagnet. It's the electricity affecting it that causes the magnetic field. So if you imagine, this is just a thought, if you imagine if that electric field changed radically in a short time, perhaps it could flip the Earth over. That's a thought, isn't it? People talk about polar reversals, and the magnetic poles are already moving, but could that affect other things? It's a thought, isn't it? Anyway, Don Scott's done a lot of work on comparing electrical devices actually with what we see in space and what we see with the planets and so on. And he's showing how an electrical device here, you get an anode and you get a cathode and you get a flow, and the Faraday dark space, you'll have plasma flowing through there, but it'll be in dark mode. Anyway, I'm not going to go into that. Another diagram he uses, he's showing how you get different flows from the sun depending on whether the positively charged particles are going out through the black spots, what we call sunspots, from the end. You have to understand the inside the sun is much cooler than the outside. It's very odd, isn't it? But there can be a flow of positively charged particles going out through the black spots, sunspots. But you can also get ions that are going out through the coronosphere, what they call the tufted spots. And one of the things he's explained, he'll explain it much better than I am at the moment, but the ones going through the sunspots can get out with much lower energy than the ones that are coming out through the outer, illuminated part, because they have to have very high energy to penetrate that. And he's showing that with a kind of hill here at the top, and he's showing lower energy ones lower down. I'm going to give you links. You can, if you're interested in all this, you can do so. But the important thing is that they do know from astronomy that the sun, what they call the solar wind, is composed of slow-moving particles, but also much faster ones. And they don't understand why some are so much slower, different flow rates than the others. Well, Don has an answer to that. He's explained it very well. Now, the other thing I wanted to show you was in outer space they found Birkeland currents. You can see how they very often there are twisted pairs like this, and how stars are connected one to another on strings. It's like strings of pearls. Or another way I like to think of it is, you know, with Christmas tree lights, you have all these little lights, don't you, on the same wire, and you twist the wire around your tree to illuminate it with all these little lights. Well, it's sort of like that with the stars. They have the same big current, Birkeland current, linking up the stars together, and actually the stars are formed on the Birkeland current because, as I was saying, the larger the flow, the more it constricts, and at certain points you get what's called a Z-pinch. I should say Z-pinch in English. A Z-pinch, they always talk about, that compresses matter, and that in the electric universe model is how stars are born. But more about that later. Another person who's been very active in all of this is Monty Childs. And again, I've met him, and he came to the conference we had in Bath in 2018. He's part of the Sapphire project, which is an independent group checking out, doing rather like Birkeland was doing, but in a more modern way. And you can see the machine behind you there. And they had an anode and big plates to act as cathodes, and a chamber that they could totally evacuate, and then they could put very small amounts of different gases in. It could be hydrogen, could be argon, could be nitrogen or oxygen, whatever they wanted to put in there, they could do that. And they could also vary the voltage between the anode and the cathode, and they could vary the currents. So they had these different variables, and they also had what are called Langmuir probes. And I'm not going to try to explain that too much, except to say that plasma, when it's in stable situation, carrying a current, it forms these what are called double layers. And it's very odd, very, very odd. It's not what we'd expect at all, but you can get layers of positive, negative, positive, negative, positive, negative, and separated by little gaps. And they could poke a thing into there, the Langmuir probe, and they could measure the voltage of these different layers. They're doing all that sort of work, you know, very, very amazing. But it all comes down, really, you'll see it with this picture. Now you can see the double layers, and you can see how the anode in the middle there has these tufts on it, which are very similar to what you see in pictures of the surface of the sun. And you can see the electrical field going out and the plasma separating out into these double layers. This is very advanced physics we have here. We're explaining how the sun generates energy and how the energy is actually coming to it from outside. It's not an exploding atomic bomb. Get that out of your head. That was a very stupid early 20th century when they were playing around with nuclear bombs and, trying to make the first atomic weapons and all of that. They were thinking atomic explosions, but everything must be atomic explosions. It's not. It's to do with electricity and electrical flows. It might sound weird, but this is the physics of the future. And they've actually are now, with this experiment, they've gone beyond proving how the sun works to turning this into a device for actually making electricity get more out than comes in. It actually converts atoms from one element to another. It does alchemy. And in the course of doing that alchemy, of course, energy is released. So they have actually got a nuclear fusion reactor. And I know that it's all gone very quiet for the last 5 years on this. Big money is getting involved. And the American government's involved, people like Lockheed Martin are involved. You can expect that people are going to be producing these atomic fusion reactors based on this model in the not too distant future. So that's what's happening now in practical terms with the electric universe ideas. So there you can see the Earth in its Van Allen belts of ionized plasma around it. That's what it is. And we're back to Benjamin Franklin with his key, and he thinks the lightning, the electricity is coming out of the clouds, but actually it's not. They've now found out that above the clouds you get these sprites, as they call them, which reach up from the clouds when there's a thunderstorm, reach up, go way up into the ionosphere. So lightning is actually beginning way out in space, and the energy coming down from there, linking up with the energy from the Earth, and that's when you get the flows of energy. And lightning is to do with the Earth balancing up its electrical forces, and it receives energy in the form of electricity from the sun. Sometimes there's a bit too much, sometimes there's not enough, but it balances things out using lightning and storms, and that's what causes it. So, yeah, amazing, isn't it? Way over my head, really, to be honest. But I do understand it somewhat, and I understand from that this is how the electric universe works, and it's what has been hinted at way back by Robert Fludd in his diagram of God with his chain going down to the wrist of Mother Earth, nature. That chain is probably a Birkeland current, a very large one, and God is the puppet master who controls all of these currents ultimately, the currents that create and destroy, the currents that nourish, everything. He's the puppet master. It's the great unknown behind it all that controls everything. So I hope you enjoyed this little lecture, and I'll put the links below here when I publish this, and you can particularly follow up some of Don Scott's lectures. He's very good, and I'll be discussing further programs in this series. And what I'm going to do is I'm going to take specific subjects now, and then I'll talk about the person who's done the most work on that, or maybe more than one, and I'll put links to their stuff. Most of it's been done with the Thunderbolts group, thunderbolts.info, and so you find a lot of those lectures will be people who've done work within that context. But now you know a bit more about the general ideas, you'll be in a better position to understand what they're actually saying. And I would recommend that you get some books on the subject if you want to take it further, and you can work on it that way as well. And if you're a scientist yourself, you might find this is an area you'd like to get involved in. So I wish you well. Bye-bye.